Welcome to Kishore's Neet Padasala. In this video lecture, we will deal with certain numericals of the Newton's laws of motion chapter. Okay, this is an FT graph and they are asking change in the momentum. Change in the momentum is nothing but the impulse imparted. Okay, so which is area of triangle plus area of rectangle minus area of the square, since it is along the downward direction. Okay, area of triangle is 1 by 2 into base into height, plus area of rectangle is, this is 4 Newton, sorry 4 seconds, 4 into height is 3, minus area of square is side into side, 2 into 2. So the answer is 14 ns. This is the impulse or the change in momentum. Okay, a body of mass m hits normally on a rigid wall with velocity v and bounce back with same velocity. Impulse they are asking. So see that a body of mass m, it is moving towards a wall with speed v, and again it is moving this way with the same bouncing back with same velocity v. They are asking impulse. This I am taking as positive direction, this I am taking as negative direction. Impulse is nothing but m into v minus u. So m into final velocity, since it's along the negative direction, I am taking minus v, minus initial is positive, so plus v. So m into 2v, that is 2mv is the impulse created. Minus 2mv, if they are asking modulus, then it is 2mv. Okay, this is a common type of numerical. Now let us see this thing. Okay, now let us solve the components for this question. Along the angle, it is v cos 30. Away from the angle, v sin 30. For this thing, away along the angle v cos 30, away from the angle it is v sin 30. Okay, so initial velocity before bouncing is, I am taking this along the negative axis and this along the negative axis, since it is so minus v sin 30 I cap minus v cos 30 j cap. And final velocity after bouncing is, first I component, this is also along the negative direction, so minus, it is plus direction I think, so v sin 30 into I cap. Okay, and sorry, it is minus direction only, since it is in this axis, it is minus direction, so minus v sin 30 plus I am taking, since it is pointing above, v cos 30 j cap. Okay, this component is minus, okay, and this plus component is because it points in the upward direction, so vf minus vi, if you do, it is, if you subtract these things, you get 2v cos 30. Okay, 2v cos 30 is nothing but 2 into v into v is 20 into cos 30 is root 3 by 2. So the answer comes out to be 20 root 3 ms per minus 1. Okay, this is the change in velocity. Now let us see this question. This is a common type of question. A gun fires n bullets of mass m per second with speed u. So n bullets is firing with speed u, and this is the positive direction I am taking. All gets reflected back this with the same speed u. This is I am taking as negative direction. So force into time is per second they have given, so which is 1 second is equal to m into, since it is for n bullets, I am multiplying it by n. For 1 bullet the mass is m, for n bullet the mass is nm, into v minus u. Final velocity is u, but it is the negative direction, I am writing it as minus u, minus initial velocity is plus u, since it is in the positive direction. The answer comes to be 2nmu. minus 2n mu. So this is the force acting on the wall. Now let us see another one numerical. See, a particle of mass m strikes elastically on wall with v, velocity v, at an angle 60 degree from the wall. So see, a ball is bouncing at an angle 60 degree from the wall with v, speed v, and it again bounces back with same speed v at 60 degree from the wall. Find the magnitude of change in momentum. I have directly said that if they are given like this, which is 2 mv sin theta is the change in the momentum. So 2 into m into v into sin 60 is root 3 by 2. So the answer is root 3 mv. Okay, suppose if this angle is theta, okay, then change in momentum is 2 mv cos theta. Directly you remember. The previous video I would have worked out the steps, but in this, from now you directly remember this as a formula. I hope you like this lecture. If you like this lecture, please subscribe Kishore's Neet Padasala. Thank you.